Good afternoon, everyone. I'm going to be speaking to you this afternoon about 60 years of marine diamond mining on the southern African continental shelf. My perspective of perhaps some conservation lessons that were learned and should and can be remembered for the mining of our green future. If one considers Wikipedia as an authoritative summary of the definitions and history, and I'm obviously not sure that we should, then deep sea mining is apparently the retrieval of minerals and deposits from the ocean floor in depths greater than 200 meters. Now, that's somewhat arbitrary, and I question it. But for now, if we just look briefly at the major types of mineral deposits that are being sized up by intrepid explorers in the oceans for mining on a large scale, they basically fall into three categories. We've got the polymetallic nodules, which contain significant quantities of rare earth elements: cobalt, nickel, copper, molybdenum, lithium, and yttrium. They occur on abyssal plains as chemical precipitates from seawater. Polymetallic sulfides, which contain quantities of copper, gold, lead, silver, and occur mainly as extinct hydrothermal vents in previously tectonically active geological terrain, such as mid-ocean ridge spreading centers. And then cobalt-rich ferromanganese crusts, which also contain tellurium, nickel, copper, platinum, zircon, tungsten, rare earths. And those are on seamounts, which have been swept clean of sediment and also chemical precipitates. Now, cobalt is common to both polymetallic nodules and ferromanganese crust. And to put them into perspective, according to the International Seabed Authority, I think it's something like 6.3 million square kilometers, or 1.7% of the entire ocean floor, is covered by cobalt-rich crusts containing perhaps 1 billion tons of cobalt, which would be enough cobalt for more than 1,000 years. Now, currently, there's supposedly no commercial mining of seabed minerals per the definition of so-called deep sea mining, and again, according to Wikipedia. But I include two groups of images here. One group is of a conceptual mining tool for the deep sea mining of polymetallic nodules. The conceptual example was never actually used in anger, so to speak. The other pair of images is an illustration of an underwater mining tool and illustration of crawler-based mining methods that have been in operation for the mining of marine diamonds since 1990 and are set likely to continue until at least 2042. So as we speak, this monster here on the right-hand side is on the seafloor as we speak, sucking up gravels, and the ship above it is extracting diamonds. So for me, it's wrong for us to say that there's supposedly no commercial mining of seabed minerals currently, given the debates that are raging and will take place in the future. It's a missed opportunity for those involved in these future debates not to take cognizance of what has happened and is happening, to learn from those experiences when it comes to what it takes for any such large-scale deep sea mining activities to be conscionable. So, given that I'm not a fan of Wikipedia's definition being tied to an arbitrary number of 200 meters water depth, I prefer my own criteria for determining what does and doesn't constitute deep sea mining, and one which encompasses marine diamond mining example for reasons that we will see. So for me, it's nothing to do with deep sea mining, is obviously nothing to do with hydrocarbons. That's sort of old hat by now in terms of the debates regarding conservation and environmental issues. It involves for me resource development and mining of at least areas that are of at least provincial magnitude. You won't find them on reality television, such as Bering Sea Gold on Discovery Channel, and they should be independent of adjacent coastal infrastructure and safe havens. And as I've said, I would argue that depth of mining is not a relevant variable. And as such, the large-scale marine mining of diamonds on the southwest African continental shelf is an example of deep-sea mining, and therefore relevant to current and future debates around conscionable deep-sea mining. It's something of a broad brush conventional wisdom that southern African hinterland kimberlites are the source of the West Coast diamond deposits, one that's been proven fairly unequivocally. Various estimates have been made as to how many diamonds were eroded from exposed kimberlites. One such estimate is a ballpark of about 10 billion carats, of which 7 billion carats were likely destroyed by attrition during the trip in rivers to the coast and during high-energy marine processes on the actual coast. And what is shown here is the drainage patterns in South Africa as they've endured for at least the last 90 million years or so. The point being, a few complications aside, is that there's been a long-lived westward drainage system delivering diamonds to the coast for many tens of millions of years. Perhaps some 95 million carats have been mined from the Namibian deposits, both onshore and offshore, with there being a known resource of at least some 80 million carats remaining. And fewer have been mined in the more southerly Namaqualand coastal deposits. Diamonds were first discovered in Namibia near Luderitz in 1908, and by the 1950s, onshore mining had reached upwards of 1 million carats per year. But it was not until 1958 that an intrepid explorer by the name of Johan Verveer, who founded a company called SWA Prospecteerders, recovered the first marine diamonds through scooping up gravels in the shallow marine environment and treating them on shore. In 1961, Texas oil pipeline contractor Sammy Collins, who was installing a pipeline installation offshore of Aranyament, recovered marine diamonds from a specialized marine mining platform. And by 1964, his production had ramped up to 241,000 carats of diamonds in 1 year. Marine production waxed and waned in water depths shallower than 30 meters and eventually ceased in 1971. But between 72 and 82, exploration activities by De Beers, who had at that stage acquired a majority share of Collins's company, they identified a very extensive but relatively low-grade diamond deposit on the deeper shelf in water depths greater than 90 meters. And it was only from 1990 onwards, though, that this large-scale production of this deposit commenced, with the first haul of official mining production of 29,000 carats, thereabouts in 1990. And this ramped up quickly to 1 million carats per annum by 2006, and save for the global economic crisis of 2008, which caused production to dip in 2009, marine production has not since dipped beneath 1 million carats per annum and now accounts for nearly 80% of all diamond production in Namibia. Namdeb, who holds the mining license, recently announced an extension of the long-term mine plan to 2042, by which stage they would be just 16 years shy of a nearly 100-year, a century history of mining of diamonds from the ocean offshore of Namibia. And that to me is really remarkable. For me, it's looking at the current active exploration and mining fleet, which gives one a sense that this is what deep sea mining looks like. This is what deep sea mining of minerals other than diamonds, perhaps especially cobalt, could look like in the future. There's currently 9 ships actively exploring for and mining diamonds on the continental shelf offshore of Namibia. And this is excluding a brand new mining vessel, which was purpose-built from scratch and which will be deployed later this year once it's been fully commissioned, and which will reportedly increase marine production by a further 35%. These ships work on a continuous operations basis, 365, 24/7, and remain at sea for 3 years at a time before scheduled imports and dry dock for maintenance. And it's when one beholds the sort of scale and sophistication of the operation that it becomes a bit of a struggle to reconcile the arbitrary 200-meter cutoff for what does and doesn't constitute deep sea mining. And for the purposes of debate, this West Coast marine diamond mining operation has to be considered as a precedent for what could occur in the future with regards to mining of other minerals from the ocean. The geological situation on the coastline today is one of a spectacularly denuded Cretaceous surface, part of which is the so-called KT boundary or Cretaceous Tertiary Unconformity surface. This surface is the product of several kilometers of down wasting through erosion, and overlying these fine-grained, generally clayey Cretaceous sediments are relatively more flat-lying, coarser, silty, sandy, and gravelly or conglomeratic terrigenous clastic units deposited on the shelf during various sea level low stands. It's the erosion of these units which has resulted in their being present over a large surface area of several thousand square kilometers. A diamondiferous resistate gravel lag, varying in thickness from just a few centimeters to perhaps a maximum of a meter or a couple of meters. The distribution and thickness, as well as the distribution of diamonds, is extremely variable and very much keeps my former geologist and geophysicist colleagues very busy figuring that out and developing a resource ahead of the mining fleet. In contrast to an aerially extensive thin gravel lag mined on a large scale by generally high mining rate vehicles, more localized so-called fixed trap sites eroded into the inshore hard competent crystalline basement between 30 meters and say 90 meters. And these are mined and have been mined more sporadically by various incarnations of mid-sized marine diamond mining companies such as Namco, Samicor, Diamond Fields International, and Ocean Diamond Mining. From a non-environmental practitioner's perspective, i.e. my own perspective, there are a few variables that even myself as a geologist could appreciate firsthand. One was able to get a firsthand sense of there being a spectacular contrast across the mining license of biodiversity and faunal abundance between those rugged, rocky, exposed strata areas and those areas covered by thick silty sediment of the Orange Cone closer inshore. I've got really fond memories of watching seals firsthand catching fish and cuttlefish right in front of my eyes whilst in the Jago submersible at water depths of 125 meters. I've also witnessed firsthand events of churning up of the silt in the lower 8 meters of the water column as a consequence of winter storm, high amplitude, long period swells, which are characteristic of the Orange River coastline. I believe such events, or I understand that such events suppress faunal abundance and biodiversity in the area close to the Orange River relative to the more rocky distal areas away from the cone. I've also observed kingklip in 130 meters of water hiding under ledges cut by waves in amongst diamondiferous, cobbly, terrigenous gravels. To some extent, it's actually the geology which determines the environmental parameters, and it's a broad brush statement that the thicker sediment-covered areas recover more quickly from the mining operation than the rockier areas further to the north and offshore. The environmental assessment process in Namibia is very robustly governed. Critically, ongoing exploration and recovery cannot be undertaken without an environmental clearance certificate, which looks like the one on the left there. These are valid for a period of 3 years. They're strictly conditional, and they're awarded as a culmination of a very comprehensive and broadly consulted process, which you see on the right. Additionally, Namibia, as a UN member state, is obliged to adopt and has adopted legislation to reduce marine pollution from seabed activities in the EEZ and on the continental shelf. I realize perhaps that the title of my talk and the abstract may have created the impression that I would be revealing the specifics of what lessons were learned. Alas, though, as an exploration geologist, I'm nowhere near qualified to expound on the merits and demerits of the environmental management and regulation aspects of the marine diamond mining operation. Suffice to say that the operating company DevMarine Namibia has a robust, sincere, and comprehensive environmental management framework as a consequence of operating in a mature and strict national and international regulatory framework. Amongst the senses of comfort that I used to enjoy as a non-environmental practitioner involved in exploration and resource development was the fact that DevMarine maintained an ISO 14001 environmental management system for all areas of its activity. Additionally, the locality of the mining area is serendipitous in a few respects, namely that the impacts of mining are considered to be of low significance given that the area of a shelf affected by mining to date remains low at less than 1% of the total shelf area of the southern Benguela outer shelf region. The benthic fauna are characterized by widespread generalist species, and the area affected by mining is not considered to be especially important as a spawning and nursery area for commercially important fish species. This is obviously not to say that there aren't environmental concerns and sensitivities, as summed up by this map, which shows such issues including seal and marine bird breeding colonies, sensitive pans, rock lobster sanctuaries, and rock lobster commercial fishing areas. Interesting, though, if one reads through the EIA, one gets a sense of irony that perhaps the main phenomenon for the serendipitous low significance of mining activity, namely the high volumes of sediment input from the Orange River and relatively low biodiversity on the sediment cone itself, an area including the mining license has now been flagged as a so-called ecologically or biologically significant marine area, or EBSA, in terms of the UN Convention on Biodiversity, Marine Spatial Management and Governance Program, or MARISMA. I've highlighted it in yellow over here on this map. Reading through the EIA, one can get a sense of something of a disconnect between the views of the environmental practitioners directly involved with the mining, both inside and outside of DevMarine, and those practitioners of MARISMA, and that will be an interesting one to watch in the future. Chiefly, it seems that there's debate around whether the actual boundary of the EPSA can be justified on robust scientific basis, such as faunal abundance, variability inside and out, and uniqueness of the diversity of faunal assemblages inside and out. For me, what's made this long history of mining and what will make future mining operations conscionable, besides the serendipitous, arguably insignificant known impact, amongst other things, is the robust and strict national framework for environmental assessment and management, an internationally accredited, sincerely intended, externally audited, continually improving environmental management plan, which is ISO 14001 accredited, extensive baseline and ongoing environmental impact and recovery surveys, and external involvement in those and transparency with regards to those findings, as well as observance of international convention obligations, but perhaps most of all, a genuine will to mine responsibility. I believe all of those ingredients are present as part of the marine diamond mining operation there on the West Coast. I have to mention also the many dedicated, passionate, and excellent world-class environmental professionals, both inside and outside the mining companies, that are managing and monitoring this operation like a hawk to ensure that it can be held up as a conscionable example for future debates around marine mining of other minerals. I thank you for listening, and I offer the following 2 links as additional reading of interest.